I gave you this note sheet for us to review on how we're going to attack those multi-step problems, okay? Like I said, it's not specific interest or specifically increase, decrease, or anything like that. It's talking about how do we make sure everything's asked. Look at those bullets, okay? Take a second and look at those bullets. Read the first one to me. Read that first one to me. What does it say? So, identifying what's asked. You can already see, I saw some of you looking at it when I handed out the papers for number 14. So probably about half of my people only answered that first part. They're only answering the part where it said, Andy, to determine, explain and identify Andy's flaw in his reasoning. Everyone was able to tell me that. Okay? What do you think people forgot to do?
Solve it.
Solve what?
Figure out the actual percent.
Figure out the actual percent of what? Change. Good. Okay, so it's not only looking at this and say, oh, percent increase, I know how to do that. You have to answer all the parts asked, right? What does my second bullet say to do?
Use known criteria to text.
Okay, use prior knowledge and criteria. Well, at this point, all of our prior knowledge is criteria, right?
Mm-hmm.
I have no new material right now. If I throw you percent increase, percent decrease, interest commission, you can go back into that prior knowledge part and apply that criteria, right? And what's that last bullet say?
Determine answers logical and answer plus the rest.
Good. So I'm kind of rechecking part number 1. Did I answer every part that was asked? And then the biggest part, is it logical? Okay? Remember when we talked about that commission question on the first test and some of you put, yep, she got paid 133.3% commission. Logical? No. Okay? So you got to just analyze the numbers, determine it's logical. So right now, I'm going into student mode. Okay? I am answering number 14, your most missed. What you're doing, huh? It was. Okay? It was my team's most missed. Okay? Why do you think it was most missed? Do you think I gave a lot of people 1 point?
Yeah.
Do you think I gave a lot of people 2 points?
No.
Okay? All right. We'll talk about what you made after. Okay? I'm going to turn into a student for a second. What you're doing, I don't want a novel. You know I never want a novel. Okay? I want you to take me a couple notes underneath each bullet. I almost want you to quote me. Okay? Like, what are some questions that I'm asking myself when I'm doing this part? What are some questions? What are some things that I'm saying? You know, there's some things that I say 100 times a day. Like, what are some things that I'm saying underneath those bullets? Doesn't it need to be complete sentences, anything. Helpful notes for you, okay? Because this is not a interest lesson. This is a how do I attack a big problem lesson. Got it? So I'm turning into a student for a second, and I'm solving this. All right? We already read through it, so I'm going to kind of just jump in from there, right? So I'm going to start with my first bullet. I'm becoming a student now. All right, it says that I need to identify and explain the flaw in Andy's reasoning. All right, so I'm going to have to identify the flaw and explain. And I need to determine percent of change. All right, well, I know from reading the problem before that in 2011, the population was 1,500. I know that in 2012, it increased. Okay, so it's increasing by 1%. All right, so it's increasing by 10%. And then I know that in 2013, okay, it's decreasing by 1%. Andy's reasoning says that these cancel out. But I know that Ms. Stoop said a million trillion times that percents of a number, of different numbers, can never be the same number. Right. So right here, I know that Andy is wrong. So I'm just going to make a note before I start typing and illuminate after, that Andy is wrong. These can't cancel out because I'm going to have a new total here and a new total of kids here. So this cannot be right. But I do know how to find percents of number, pretty simple. And I know that I can get my 2011 total and then my 2013 total to find my percent of change. So now I'm going to jump to my calculator, and I'm going to say that if he had 1,500, I need to find 10% of that. Well, I can very simply do 1,500 times, oh wait, if it's increasing by 10%, I can include the whole there. So I can say times, I remember Ms. Hughes showed me that I can include that whole. I'm including the 10%. So I can say 1,500 times 1 whole and 10% equals 1,650. Now 1,650 is my new total in 2012. But that's not my end goal here. I got to get to 2013. But now I have a new total. I'm getting 2013 has 1,650, but now it's decreasing by 10%. Andy thought this would get me back to 1,500. But I can say that 1,650 times, all right, I got to decrease by 10%. So I remember when she taught me about taking a discount, even though we're talking about people here, if I'm taking 10% off, I'm counting 90%. So I can say 1,650 times 90 here, 1,650 times 90%, and I have 1,485. So right here, I already proved that Andy is in fact wrong. You won't get back to 1,500, but I'm going to start thinking logically now. I'm going to go to that logical piece and say that in 2011, there was 1,500 students, and now there's 1,485. It didn't change by much. Okay, so it only changed by 15. And I know that my percent of change formula, I'm going back to my percent of change criteria, difference over original, and I'm going to solve for that. 15 as my difference, 1,500 as my original, over 100, I'm going to write my equation. 1,500x equals 15,000. That's mental math because I just have to drop that 0. And I'm going to say that my percent is 1, but that's kind of a crazy number. So I'm going to go back and see if this is logical. I'm going to say that in the grand scheme, that didn't change much. It only changed by 15 students in 2 years. So the percent of change shouldn't be that big. So I'm going to go back and make sure that I have everything that is asked. Did I identify the flaw? Yes, Andy is wrong. You can't have the percents of 2 different numbers being the same number. And I identified the percent of change as 1% of change. And that's logical because it didn't change by that only 15 students in 2 years. So I answered all my parts and my answer is logical. All right, Landon.